Hello and welcome back to Stationeers. I'm Mick. We're back in our Mars workshop here because we are going to try programming our sorter today. Now last time we did the program exercise on bit mapping and bit masking, so if you haven't had a look at that one, go have a look at it because we're going to be using some of that stuff today. Now this machine here is the sorter. Now we have a sorter, and if you use your scroll wheel, we have a logic sorter. Now sorter is the basic one that you put down by default and use the computer to program. It'll compute the sorter card to program. We're going to look at the logic sorter. This one allows us to program it via, logic. So we'll put you down there. I've got a little input chute there just so as I can chuck stuff in it a bit easier. Now, the first thing we're going to do is, because in all my time of training people to do stuff properly, you've got some people that sit there and look at you stupidly and say, what do I do? And other people who actually make an effort to do something. So we're going to do the thing which turns a dimwit into an expert on most things there. But we're going to read the instructions. So we have our instructions there. Now this contains internal memory. So it has a stack in it, which we can write commands to help it, sort stuff. So we've got here, it is made from the sorter kit, which we've just done there. It has input, export slots, and data disk, same as the other sorter there. Now we notice it has a mode. Now it's a 0 for all, any, and none. So that's probably got something to do with the sorting criteria we put in there. We'll find out as we go. It has its standard logic there. We clear our memories. The mode there has import and export counts. Now our mode was that. We don't have a setting in this one. So we can't use it as a manual sorter. You have to put the codes in there. Okay, so we have the codes, of course. So we can filter prefab hash equals. So if something equals something, we can put it in there. Filter something doesn't equal it. So that'll be handy. Class compare. So if it equals the class of an item, because all the items, a lot of the items have classes on there. Our filter, we can sort by type. So have a type and a class. Not quite sure what the difference is between the two of them there, but they're different. We can filter by quantity. And we can limit it by the number of times. So if we just want to get one stack of iron, we can sort of say, we want iron and we only want it by one. So we put multiple codes in there. So these ones are constructed. They are a bit mapped information. So we're going to have to do that. We're going to have to do what we did in the last programming exercise to construct these commands to pass into the stack. So that's what we've got there. That's what we're working with there. Of course, we've got a logic slots. Though we're not going to use any of the slots there because we're going to program it to do what we want. Now I guess that's about it. Now this sorter instruction is a matrix constant table that is built into it. So you can write sorter instruction filter prefab hash equals, or you can just put in a 1. Now, obviously typing it in, 1, is a lot shorter to type than sorter instruction filter prefab hash equals. But when you come back to read it later on, I can look at that and know exactly what I've been doing. If I look at 1, I'll be thinking, what the hell was 1? So it's a case of, do you save time now or do you save time later? So we will be typing in the full amount there while we do it there because it just makes life easier. I can copy it. Okay, maybe there's less typing there. Okay, so we now want to get into it. So we've got a machine here that has a stack in it. Now, can I set something up to just read the stack? Let's see how we go. So we want maybe 4 items. I might grab another chip, put up some displays, and just see what the last 4 items, well, the first 4 items are in the stack. Right. That, well, shouldn't take long. Well, it won't take long for you because I'll edit it out. Okay, if I've done that right, these should be our first 4 positions of the stack from that thing. They're all set to 0 at the moment, as we expect. Now, if I switch to the other one, and get you. Now, if we switch to the other one, now I want to put an item in there. Now, I should just be able to put items in. I shouldn't have to put it into a loop. I should just be able to feed items into there once and they go into there. So I shall alias the sorter to the D0. Now I should just be able to construct the command and put it straight in there. So if we look at our command list, we shall just put in a prefab hash equals. So I've got some copper cables over there. So we just want to put in our prefab hash, which has got to be in bits 8 to 39. And we need to put in our opcode, which has to be in the first 8 bits. So we're going to start at the back. We're going to put this one in first. Then we're going to push it, shift logically left 8 bits. And then we're just going to add in the opcode, which is 1 or this thing here. Let's copy that to the clipboard. Okay. So I shall grab the, well, we'll just move into R0, the prefab hash. We'll use copper coils. So, coil, got some of them. I just grab them and say, you. Now I can shift logically left. Shift R0 will equal R0, shift logically left by 8 bits. So that should give us some extra free bits on this end. So doing a logical shift means as it moves to the left, all the new bits that come on are all zeros. So now I should just be able to add in the opcode. So we add R0 equals R0 plus our opcode, which is I'll say we'll do it the right way. Sorter instruction. We do get a whole lot. Okay. So that tells us what we're doing. So anything that equals that hash should be sorted. So then we need to put that in there. So we need to put so we put into our device, which is the sorter. Of course, we do have the put D. Yes, we do have a put D one there where you can actually use the device code as well if you've not got enough pins. We're putting in the sorter. We're putting into the address what value in the stack do we want to put it. We're going to put it to 0. Be the first value in there, and our value will be R0. Export you, and I need to set you up with the logic sorter. That is not the logic sorter, that's an old one. Logic sorter, there you go. And you're good. You're on. So now this is the accept slot, or that's the accept slot, that's the reject slot. So if I put copper cables in there, it should accept them. So we've got the value in item 0 of the slot, so that has changed from a 0 to that. So anything else we put in there should be rejected. And you're all rejected. Of course the cables are accepted. Okay, so that looks like it's working for us. So it's just a simple command. Now we need to have a look at, I can find my, it's in my pocket. all things. Now we have this set up. It is set to mode 0. So mode 0 was to match all of the requirements there. So if I put in another hash code, which is different to the cables, does something in there have to be a cable and, say, a frame? An auto lathe kit. We'll say auto lathe kit. So I grab you. We shall just put in another one there. So we shall move into 0, 1. Auto lathe kit. That's what we've got there. So if we say for you, and then copy. Copy you, and we should put you to item 1. Right, so we've got spot 0 in the stack. This should go to item 1 if I export that. Right, we've got our next item in the stack there. So now we have auto lathe and cables. Will it sort auto lathes and cables, or will it say this is not a cable and an auto lathe, so I reject it? I don't know. It rejects it. Auto lathe. It rejects it. It'll reject everything. Okay, so if you've got 2 different types in there, it rejects it. So we'll have to change the mode. Go back to you. So we had our mode. We're set to all, any, or none. Why would you set it to none? I don't know. But we shall set the mode to 1. That should allow us to sort either of those things there. So we shall first have to say a save to the sorter mode 1. Spell S right. It'll work better. So I export that. Now everything's still the same here, but now it's set to an all mode, or any. So it should be able to satisfy any of those conditions should be matched. So the cables satisfy the first condition being a cable, but not any of the other ones. So it should accept that, which it does. The auto lathe, that's not an auto lathe, that's a stacker. Stacker doesn't match any of them, it should be rejected. Right, windows should be rejected, the walls. Auto lathe does match the second item there, it should be accepted, so it is. Okay, but why would we want something that has an and in there? All conditions, because I can actually limit it by number as well. So if we say, let's find out how many we got. We've got 31 cables there. So if I say, where are we? Well, let's get rid of that. Let's put it back to mode 0. So we need to, let's leave it this way. Let's leave it this way. So we've got cables that sit in there. If we also, because we can limit it by number as well, which is quantity compare. So if I pick that, so we need to have the quantity, and we have a condition operation in there as well. All right, we're going to have to play with that one there. So we're going to have quantity condition operation. So that's probably going to be a greater than or less than type of setup there. So we need to put in our quantity. We need to shift left, put in our condition operation, shift left another 8, and put in our operation code, which is U. Okay, let's have a look. So we want to move into R0 our quantity, which we said was 31. Now shift logically left, R0 by 8. We want to put in our op code, our sorter code. by which we don't know yet, so we shall go there. We shall shift logically left again by 8 bits, and we shall add our quantity compare, and we shall I've moved my put command away again. Right, put you up to there, and we shall then put you into the sorter number 2, 0. Now our condition operation. Okay, it looks like we've just got constants in there for it, so we're just going to use them. We should have them for, well, we've got to make equals there. We should probably find them then for greater and less. That's probably what we're looking for there. It's not very well explained in the instructions on that one there, but we can find out condition operation. We're just gonna guess. So we shall say if it is equals, if it equals 31, that should be accepted in our sort. Confirm. So this one should go into the next slot up. Export. It liked it. Now, well, it's matching cables, isn't it? Right, so I put 19 of them in. They don't match. They should be rejected. I put 31 in. They still get rejected. Awesome. So we set that to 8-bit shift. We shall set our mode to any. Export you. So now, try again. 31 is accepted. 19 of the same thing is rejected. Now our stacker does not meet any of them. It should be rejected. Auto lathe does meet the criteria. That's accepted. And the cables are cables, and they're 31, so they get accepted. Right. So now if I say set it to mode and, if I set it to mode and, it has to match all of those things there. These two should mean it rejects everything. So we'll see. So well, the cables, they match 2 of the requirements and they still get rejected. Rightio. So it will reject everything if we do that. So let's remove this one here. So we shall start by saying clear. I can clear the sorter. So that'll clear the stack and get rid of all the old commands. So now when we punch the new ones in, I shall get rid of that one because that's stopping everything from working. If we export you, the second one's gone. So we now have the number and the cable requirement. Okay, so 31 of them meets the number requirement, but it is not a cable. Cables, 31 cables, they are accepted. Now if we split you in half, your cables, not the right number, you get rejected. Right number, you get accepted. Right, so that is required. It will only give you that item of that number. But because it's set to and, you cannot produce the 31 plastic sheets or 31 of them. Or you just take 31 of everything. Matching all of them does limit you a bit. Okay, so let's go back and see what we can do. Limit any. So our next one there was filter hash not equals. So if I say, change that to not equals. Right, so we're going to use the filter prefab hash is not equal. So if it's not equal to cables, but there are 31. Okay. let's just get rid of this first. I've really just got to get rid of the put command, don't I? Right, so anything that's not equal to cables should be accepted now. So if I export that, we only have the one instruction in there. So you're not a cable, you're accepted. You are a cable, you are accepted. Oh, okay, so anything that's not cables looks like it's being accepted. So now if I put something else in there, which is not a cable, so this was the, what was that? That was the auto lathe. So we can say not equals. So anything that is not equal to cable, so it's got to match any. So our mode is set to, oh, it's got to match all of them. So our mode is set to 0. It has to match all of them. So if it is not equal to cable and not equal to, that should work. That should work. They're not cancelling each other out. So our cable is a cable, so that should be rejected. That is neither. Is accepted. That's the auto lathe. That is an auto lathe. It was accepted. That's not in there. Export you. Now it's in there. Right, try again. So that's an auto lathe. Rejected. Cable is neither. So it has to match both of them. It is not a cable and it is not that. So that is fine. We can do that. So you should be accepted. If I change that to an any, that's probably going to accept anything. Because a cable is not that. So it matches one of the conditions, so it passes through. The auto lathe is not a cable, so it matches one of the conditions, so it should pass through as well. So if I put you into, yeah, so that'll just accept everything now. Okay. Right, so you've got to be careful with your mode in what you're doing there. So now I want to, let's see if we can put a number in that one. So I shall need to get rid of you, take you out of there. Now we should put our number back in. So 31. Now it will have to be in a mode where it matches all of them. So anything that is not a cable and not 31. That's very specific, isn't it? So 31 cables. Once again, we've cleared that instruction. We've now got these two here. So if we put our cable back in, that should be rejected, but everything else should be accepted. Oh. Oh, right. Yes, because that's not a cable, but there are 31 of them. So we're not saying not to this one. We've got to say there is 31. Right. Okay. Right. Right. Very good. So there are 31 plastic sheets. So if I put you into there, you're not 31. Reject. Now the cables there are 31, but it's a cable. So we reject it. Okay. Ah, confusing. Trying to combine these. There's too many of them there. Okay. So now we find that we have things like class compares. Now, well, that's, can I get the class on something? Right, we are going to look at the class. So we have things like seeds. It's not going to tell us what the... Okay. There's, as we say, more than one way to skin a cat. Logic sorter, import slot, sorting class, slot reader, large display. Yeah, nothing. Nothing. Well, you're going through too quickly. Oop. There we go. Right. So you are a sorting class 3. You're a sorting class 1. You're a sorting class 1. So what does that mean? I don't know. You're a sorting class 1. So the sheets were different. What about other sheets? Yep. Yeah, you're a 3 as well. You're also a 3. Okay, not very well documented, but it looks like the sheets are 3s and the other stuff are 1s. I think seeds are something different as well. There's different classes there. It's a bit hard to tell what they are, but let's have a look. Now, if we're going to say we are going to use a sorting class compare. Our sorting class, so we need to have our condition operation, which once again will just be in equals or not equals, and our operation code. So we want to have our sorting class, which will just sort sheets. So any sheets, so let's just say 3 and equals and our op code. So let's get rid of you and you. So we are putting in our number, which we want to have our sorting class of 3. We're going to shift logically left by 8 bits. Now we needed to put in our compare code. So add R0 and equals, and then shift logically left again by 8 bits, and we shall add in our yep, come on, get the whole lot and paste you in there. Sorting class compare. Right, so that should be anything with sheets. Set to mode all. Export that. We should have one item in the stack, all the rest have been cleared. So now all of our sheets, which are sorting class 3, should get accepted. And you, I didn't check you. Okay, well you're obviously a sorting class 3 as well. You're a sorting class 1. You're a 1. You're a 1. You're a 3. And you're a 3. Okay. So there we go. Obviously, you can sort them by number as well and sorting class. So any stack of 31 sheets of any type we can accept just by changing an AND command and putting that in there. Now, one of the other things we had in there was our limit next execution by count. So that was probably the next one we want to play there. So if we say we want to get a stack of cables, but only once, okay, or well, let's just add it in the other one. We're currently sorting by our sorting class. So any set of sheets, but we only want it once. So we need to say, well, basically the count there. So we only want one of them. Oh, I wonder if that's going to change and count itself down as it goes. Okay, we'll take a look at that. Okay, we want 2 of them. So we'll see how that goes. We're going to put 2. We're going to shift logically left, and then we are going to execute by count. So we've got you until there. We shall just keep the other ones there. They're still there, but just they don't get put into the stack there. I'll just leave them there for the sake of it. Move into R0, the number we want, 2 of them. We shall shift logically left by 8, and we shall add, add you execute by count, and then we need to put that into the sorter stack at position 1, 0. Export that. We're all good. We now have 2 items in the stack. So it had to be a stack of sheets, or it had to be something sorter class 3. Now it wants 2 stacks of these. We'll just see, will that number count down as we put them in there? First lot come in. No, it doesn't. Okay. Put in a different lot of sheets. They're still sheets. So that is counted down now. If I put in another lot of sheets, will it get rejected? Nope. But it's now counted down. Now it's rejecting everything. Okay, don't really understand what's going on there. We'll just go back to our copper cables. Right, so it's cables, and we want 2 of them. Or we want two stacks. Export you. We've got our 2 stacks in there. Now everything else should be rejected. Okay, that's as expected. My cables, which I have here somewhere, you get accepted, but it didn't do a countdown. Interesting. That time it counted down, so there's the 2 stacks that I wanted. There's a 3rd stack. Now it's not going to give me any more. Or is it? It is giving me more. Limit next one. So do I have to swap those 2 around? So if I put you to 0 and put you into 1. So if we swap those 2 around, will that make a difference? It does say limit next. If I put you back to... Okay. So now the counter is at the bottom. Limit the next one, which is that one there. Okay, immediate count on that one there. That's 2. Rejected and rejected. Okay. So, yeah, as it says on the packet, read the instructions, limit the next count. So if we say that one there, limit the next count by 2. And it does. Everything stays in the stack, so it doesn't actually clear the stack. But it just knows that it's had enough of them. So how about if I export you again? They're both in there. So is it just limiting the sorts? So if I have a rejection, so it's not counting the rejection, so it's not going to reject twice. It's only going to accept twice. Yeah. Oops. Go away. Right, so it's only going to accept things twice. Next item. Okay, that makes sense. That all makes sense. Okay. Well, I think that's probably just about it. We've looked at everything there. except for a slot type compare, because I don't know what the hell that is. So we've looked at the equals, the not equals, the class, whatever that is, we didn't look at it, quantity, and limit next execution, not previous, but next one. So we can set it to count a number of times. We can set it to count a number of objects. We can set it to filter a quantity. Yeah. Quantity and type. It can be tricky, but it can be done. So that's what we've got there. That is the programming the logic filter. It is reasonably easy to program. As I say, use the full words there. It makes it easy to read later. You can just copy them out, so it doesn't take much typing, but it makes it easy to read, so it's worth it there. I suppose one thing I really want to see is how fast does this thing sort? Yeah. Now, will it sort faster than the old one does? Hell yes, it does. Right, now we're looking for 2 stacks of cables. So if I split half, well, split half again. Right, so if I put in some of you, oh, let's try switching it off. If I put in you, a stack of cables, plastic sheets, iron sheets, another stack of cables, you, another stack of cables, and can I put something else in there? Nope. It should put 2 stacks of cables out here. The other stack of cables should end up on this side. How quickly can it sort them? I think that's quicker than the other sorter. Okay, so you don't need that silly sorting card there, which has just got an awful interface on it, but it's one of those things where you sort of say, well, how would you do it better? I don't know. This is probably how I'd do it better. So you can either use that, or we can use this thing. Takes a little bit more know-how to do it, but it's quicker, and I think it gives you more options. So using the logic sorters, I think, does improve on the previous ones there. So, but anyway, that's about it for today. So till next time, happy building. See ya.